Hello there. Now we go on to climate. Now the climate refers to the interaction between the 5 parts of the climate system to produce a long-term average weather of a location. Now these 5 parts of the weather system are the atmosphere, the hydrosphere, the cryosphere, lithosphere, and biosphere, and some of it we have covered in the other topic in a separate video. So what affects the climate of a location, right? In other words, what affects the interaction between the 5 parts of the climate system? Do you recall these 5 systems? I might test you. Now first, the latitude, the geographical coordinate measured in degrees that specify how north or south a location is relative to the equator. And the equator is given the value of 0, right? While the north and the south pole are given value of 90 degrees. So next is the altitude. The altitude is a geographical coordinate that specifies how high a location in relation to its sea level, above sea level. The third factor is the terrain of the location, and this refers to the physical features around the location. The last is the presence of nearby water bodies and the sizes. Right now, let's discuss a bit on the Singapore's climate. Now, Singapore is described to have a tropical rainforest climate, which is characterized by high rainfall and temperature all year round. But why does Singapore experience this climate, right? To answer that question, one must look at the geography of Singapore. Now, Singapore is 1.5 degrees north of the equator. Next time when you have a fun quiz, you can ask your friends, right? Many people think that Singapore is below the equator, but no, Singapore is above, north of the equator, even though we're so hot. Most of Singapore is not more than 15 meters above sea level, so we are really a low-lying country, right? If one day we don't do anything, we might be flooded. Now there is a region of the elevated land down the middle of the island, right, near where I stay, separating the east and the west, your Jurong side here, right, and the Changi Pasir Ris area. Now most of this rain of Singapore receive is from the Sumatra squarels, below near Indonesia, which is a row of thunderstorms moving into the northeast direction from Sumatra. So it's coming from the south, right, going up this way, northeast. So being very close to the equator, the angle of incidence, right, of the sunlight in Singapore doesn't exceed 22 degrees. We're saying that angle of incidence of sunlight, plane mirror light, right, hits the layer, it doesn't exceed 22 degrees. And that means the intensity of the sunlight is very high all year round, because you can see it in the middle, right, it is more concentrated. And the top here, when you have low angles of incoming sunlight, right, you see the patches is bigger, so you are being spread over a larger area, so it's more diffuse, we can say. It's less hot in the north and south pole, that's why it's a bit cooler. Now because of this reason, we are so close to the equator, we have a high annual mean temperature. I don't think we ever go below 30 degrees Celsius, at least for my lifetime in Singapore. Now, the intense sunlight from the sun evaporates the moisture on the surface, right? Because it's hot, molecules absorb energy, vibrates, and the water is the most abundant here. Now, so the water vapor and the moist air move up to the tropopause, about 10 to 15 kilometers above sea level, where the air is no longer buoyant. It can't float high anymore. Now, the moisture in the air is then released as heavy tropical rains. And because it's unable to continue to rise higher, this substratospheric air is instead being pulled downward by the continued rise of the air below. Now, because of this current here, because of this cycle here, you see what we call the Hadley cell, where there's this cycle, right, of the convection currents. Convection currents are due to the temperature gradient. Now, as the air moves polewards, it both cools and gains a strong eastward due to the Coriolis effect and the conservation of the angular momentum. This is more physics that I won't ask, but how it spins and your angular velocity. Okay, sidetracking. Now, this results the winds right from the subtropical jet stream. And at this altitude, the now cool, dry, and high altitude air begins to sink. Because it's cooling, right, lose energy, then of course it sinks, cool air sinks, hot air rises. As it sinks, it warms diabatically, right, decreases its relative humidity, and near the surface, a frictional return flow completes the cycle, the loop, absorbing the moisture along the way. So this is called the Coriolis effect, right? And it gives this flow a westward component and creating the trade winds. Now, as we mentioned earlier, Singapore received most of its rainfall from the Sumatra coast, from the south, right, near Indonesia. Now, these thunderclouds approach Singapore from the southwest direction, and therefore these clouds will reach the western part of the Singapore first. But due to the presence of the elevated land in the central regions of this island, Bukit Timah, the eastern region of Singapore gets relatively less amount of rainfall due to the rain shadow effect. Now, what is the rain shadow effect? When wind carries the moisture, right, it moves up the gradient to the elevated land, right? What happens here, right? There's a bit of cooling, and then the air becomes heavy here, and it start to fall, gets heavy, and you have precipitation, right? So before it goes to the other side, the rainfall has already occurred. That's why the other side is like a shadow. You are being blocked, sheltered from the rain. And because of this reduce in temperature at the high altitude, cause it, right, just to drop and rainfall before it can move to the other side and cause rainfall. So this casts a shadow of the dryness on the other side of the elevated lands. And these are the citations for this topic. It's very nice to go through the atmosphere. I'll see you next time. Cheers.